This is the key to the worksheet on evaluating piecewise defined functions. And so for each of these, you have to determine which part of the function you're going to use. And so the domain for each of these little parts are going to be very important when you do the evaluation. So if you look at number one, you have this function, and it is f of x equal. And so your function's equal to 2x minus 1 if x is greater than 3. And it's also equal to 3x plus 2 if x is less than or equal to 3. All right, so that's your function. So that's a piecewise defined function. So in part A, you want to find f of 5. So in other words, remember, this means what's the y value when x is 5? So you have to use one of these. And to determine which one you use, you got to look at your domain. So this says that if your x's are greater than 3, then this is the function, the part of the function you're going to use. If x is less than or equal to 3, this is the part of the function you're going to use. Well, x is 5 here. So that means that since x is 5, you're going to use this one because 5 is greater than 3. So what you're going to do now is you're going to replace, you're going to use this one. So you're going to go to f of x equal 2x minus 1. And in place of x, you're going to substitute 5. So we get 2 times 5 minus 1. So that's 10 minus 1, which is 9. So you're going to say f of 5 equals 9. Okay, so the answer for part A of number 1 is 9. All right, then let's look at part B. So in part B, you want to find f of negative 2. So again, I got to make sure I'm using the right one. So do I use this one? Do you use the top function or do you use the bottom one? Well, you're told that x is negative 2. Well, x is negative 2 here. So that's where it says negative 2 is less than or equal to 3. So that's a true statement. So you're not going to use this one because negative 2 is not greater than 3. It's this one. So I'm going to use this one. So I'm going to use this function, f of x equal 3x plus 2. And in place of x, I'm going to substitute negative 2. So I get 3 times negative 2 plus 2. So that's negative 6 plus 2, which is negative 4. And so therefore, f of negative 2 is equal to negative 4. All right, so remember what that means. That means that when x is negative 2, the y value is negative 4. So for that one, you're going to say negative 4. For part C, you want to find f of 3. Well, now, notice that this says x is 3. So what's the y value when x is 3? So you're not going to use this one because 3 is not greater than 3. You're going to use this one because 3 equals 3. So 3 is less than or equal to 3 is a true statement. All right, so that's the one you're going to use. So you're going to use f of x equals 3x plus 2. And again, in place of x, you're going to substitute 3. So I get 3 times 3 plus 2. So that's 9 plus 2, which is 11. So f of 3 is equal to 11. All right. Okay, so that was number 1. Now let's get number 2. Now, number 2, you have this function in number 2. You have g of x is equal to, and then let's see, it's x squared plus 1 when x is less than 0. So for any value of x that's less than 0, this is the one you're going to use. If x is greater than or equal to 0, if x is greater than or equal to 0, then you're going to use the fact that g of x equals negative 3. Now, don't let this little part here confuse you. You see there's no variable. That's fine. All right, so just make sure you know what that means since there's no variable with this negative 3. So that's a constant. So that says that my y value will always equal negative 3 when this occurs. Okay? All right, so let's look at part A. So in part A, you want to find g of negative 3. G of negative 3. So notice that x is negative 3, so that's a true statement here. Negative 3 is less than 0, so I'm going to use this one. So you're going to use, for that one, you're going to use g of x is equal to x squared plus 1. So obviously the variable x, I'm going to substitute negative 3. So this becomes negative 3. Don't forget the parentheses. That's important. Negative 3 squared plus 1. Negative 3 times itself is 9. 9 plus 1 is 10. So therefore, g of negative 3 is equal to 10. So part A, you have 10 here. Part B, you want to find g of 0. So g of 0 is not, that's not a true state because 0 is not less than 0. 0 equals 0, so this is the one you're going to use. Now look, you have this negative 3. So you're going to use g of x is equal to negative 3. Now, just like we did before, where we see the variable x, you substitute that value of x. Well, notice there's no variable x here, so there's nothing to substitute. So that means that y is always equal to negative 3, no matter what x is, for any x greater than or equal to 0. So therefore, the answer is just g of 0 is equal to negative 3. So for B, you're going to get negative 3. And then think about the next one, g of 4. So for C, you want to find g of 4. Well, again, that's the one you're going to use here because 4 is greater than or equal to 0. So you're going to use g of x is equal to negative 3. But the same thing, there's no value of x for you to substitute 4. So this means that y is always equal to negative 3 whenever the value of x is greater than or equal to 0. So since x is greater than or equal to 0, here x is 4, it's going to be negative 3. So g of 4 is equal to negative 3 as well. All right, so that's number 2. Okay, let's look at number 3. So number 3, we have this function. Number 3. All right, we have h of x is equal to x plus 5 when negative 2 is less than equal to x is less than 5. So you have this compound inequality here. And then it is 1 plus 3x if x is greater than or equal to 5. All right. And in part A, you want to find h of 7. So x is 7 here. So you know that 7 is not between negative 2 and 5. So you know that 7 is greater than or equal to 5. So this is what you're going to use. You're going to use h of x is equal to 1 plus 3x. So wherever you see the variable x, you're going to substitute 7. So I get 1 plus 3 times 7. So that's 1 plus 21, which is equal to 22. So h of 7 equals 22. All right, so that's part A. So you say 22. Part B, you want to find h of 3. So notice that 3 is between 5 and negative 2. So 3 is less than 5, and also 3 is greater than negative 2. So you're going to use this one. So you're going to use h of x is equal to x plus 5. So wherever you see the variable x, you're going to substitute 3. So this becomes 3 plus 5, which equals to 8. So therefore, h of 3 is equal to 8. So h of 3 is equal to 8. The next one, C, you want to find h of negative 1. So notice that negative 1 is not greater than or equal to 5, so it has to be in this one, right? Because notice, negative 1 is less than 0, and also negative 2 is less than or equal to negative 1. So you're going to use x plus 5. So you're going to use h of x is equal to x plus 5. And so wherever you see the variable x, you're going to substitute negative 1. And so I get h of negative 1 is going to equal negative 1 plus 5, which is 4, right? So h of negative 1 is equal to 4. So that's part C. So in C, your y value is 4. All right, D, you want to find h of 5. So h of 5, notice it's not going to be this one because 5 is not less than 5, right? Even though negative 2 is less than or equal to 5, 5 is not less than 5, it has to be this one. So you're going to use 1 plus 3x. So you're going to use h of x is equal to 1 plus 3x. And so h of 5 then, wherever you see the variable x, you substitute 5. So h of 5 is going to equal 1 plus 3 times 5. So that's 1 plus 15, which equals 16. So h of 5 equals 16. All right. So that's part D. All right, so the answer here is going to be 16. All right, so let's look at number 4. All right, number 4, we have this one, number 4. All right, so we have k of x. So this time you have 3 parts of this function. You have 1 minus 3x if x is greater than 6, and then 2 plus x if x equals 6, and then 2x plus 5 if x is less than 6. All right, in part A, you want to find k of 7. So what's the y value when x is 7? So since x is 7, you're going to use this one because 7 is greater than 6. So you're going to use this one. So you're going to use k of x is equal to 1 minus 3x. So where we see the variable x, you're going to substitute 7. So this becomes 1 minus 3 times 7, which is 1 minus 21, which is negative 20. So k of 7 is equal to negative 20. So if you were to graph this, where we see the variable x, you're going to substitute, when you graph this, the x value is 7, so the y value is negative 20. So you plot the point 7, negative 20. All right, so k of 7 is negative 20, so that goes here. All right, let's find k of 0. K of 0, notice that x is 0 this time, so you know you're going to use this one because 0 is less than 6. So this is when you're going to use. So you're not going to use this one because 0 does not equal 6, and 0 is not greater than 6. So it's this one you're going to use. So you're going to use k of x is equal to 2x plus 5. So I receive the variable x, you substitute 0. So I get 2 times 0 plus 5, which is 0 plus 5, which is 5. So k of 0 is equal to 5. So that's part B. So part B is 5. Part C, you want to find k of 6. So notice this time x equals 6. So this one right here, 6 equals 6, right? 6 is not greater than 6, and 6 is not less than 6, so it's this one. So you're going to use k of x is equal to 2 plus x, and you use this one. And so where we see the variable x, you substitute 6, so I get 2 plus 6, which is 8. So k of 6 is equal to 8. So that's letter C. So that's going to be 8. All right, let's look at number 5. So number 5, we have this function for number 5. We have f of x is equal to the absolute value of x minus 4 if x is less than or equal to 2, and then 3x minus 2 if x is greater than 2. All right, in part A, you want to find f of 2. All right, so x is 2. So what's the y value when x is 2? Well, x is 2, it falls here because 2 is less than or equal to 2. So you're going to use this one. So you're going to use f of x is equal to the absolute value of x minus 4. And so where we see the variable x, you substitute 2. So this becomes the absolute value of 2 minus 4. 2 minus 4 is a negative 2. And the absolute value of negative 2 is a positive 2. So the answer is f of 2 is equal to 2. So that's letter A. So that's going to be 2 here. Let's find B. So in B, you want to find f of 3. All right, you want to find f of 3. So notice that x is 3, so 3 is in this part of the domain, so 3 is greater than 2, so this is what you're going to use. So you're going to use f of x is equal to 3x minus 2. So we see the variable x, you substitute 3. So this becomes 3 times 3 minus 2, so that's 9 minus 2, which is 7. So f of 3 is equal to 7. All right. Now, finally, number 6. Let's get number 6. So, in number 6, you have this function, h of x is equal to a negative 4x if x does not equal 7. If x does not equal 7. And h of x equals 3x if x does equal 7. All right. Now notice, don't let this part confuse you here. Um, so let's look at part A. So in part A, you have h of 3. So you're told x is 3. So the question is, which one of which part of the domain does 3 belong to? Does it belong to this one or this one? Well, it cannot be this one because 3 does not equal 7, right? This part here means x not equal to 7 means any value but 7. So my domain here would be any value of x but 7, because 7 goes here. So 3 is here, because 3 does not equal 7. So that's the one you're going to use. So you're going to use h of x equals negative 4x. So where we see the variable x, you substitute 3. So this becomes negative 4 times 3, which is negative 12. So h of 3 equals negative 12. So that's letter A, negative 12. And then B, you want to find h of 7. Well, again, which part of the domain does this x equals 7 fall into? Well, it's this one because 7 equals 7. So it would be this one you're going to use. So you're going to use h of x is equal to 3x. So we see the variable x, you substitute 7. So this becomes 3 times 7, which is 21, and so therefore h of 7 is equal to 21. So that goes here. All right. Okay, so that is the key to topic 16, part A, worksheet 1, and that was the one where you had to evaluate piecewise defined functions.